Hello friends, welcome to my YouTube channel. Friends, today we are going to discuss the effect of stress concentration on the endurance limit of the specimen. So in this series of lecture today I am going to discuss the effect of stress concentration. We know that friend, when stress concentration denoted by SC, when it increases, the endurance limit of the specimen decreases, and when the stress concentration decreases, then the endurance limit of the specimen increases. The reason behind this is already explained in the previous video. The reason is that with the stress concentration, there is a sharp rise in a stress level. That is, the stress level in the neighborhood of the discontinuity will increase very rapidly because of the stress concentration. So that's why with the stress concentration, the endurance limit tend to decrease. Now friends, there is a factor known as the fatigue stress concentration factor. It is used to tell the intensity of the stress concentration. This is the fatigue stress concentration factor. Fatigue stress concentration factor. And what is the role of fatigue stress concentration factor? It is used to tell the intensity of the stress. Intensity of stress. Now friend, as fatigue stress concentration factor indirectly tells us about the stress concentration. That's why when Kf, the fatigue stress concentration factor, increases, then the endurance limit of the specimen will decrease, because it is indirectly showing the stress concentration factor in another way. So when Kf will decrease, then the endurance limit will increase. Okay friends, now we will use a factor in the design of fluctuating loads that is called as the KD, that is the modifying factor to account for stress concentration. And this KD will be equal to 1 upon Kf, that is inversely proportional to Kf, the fatigue stress concentration factor. So it is very obvious that when KD will increase, then the endurance limit will also increase, because it is inversely proportional to Kf, or KD is inversely proportional to the stress concentration, which is denoted by SC here. And when KD will decrease, the endurance limit will decrease. Now friends, the value of KD, the modifying factor to account for stress concentration, varies from 0 to 1. And this KD is used to tell us a relationship between the endurance limit, corrected endurance limit of the specimen, and the endurance limit of the specimen which was obtained from the rotating beam specimen in reversed bending loading condition. This is the endurance limit of the specimen in reversed bending loading as obtained from rotating beam test. And this is the corrected endurance limit. And the relationship bit which establish and the constant which relates a relationship between SE and SE dash is KD, that is the modifying factor that accounts for stress concentration. So here E is the corrected endurance limit, or we can say that SE is the corrected endurance limit, or we can say that SE is the endurance limit of actual specimen, which is having some kind of discontinuity due to which the stress concentration in that specimen is there, whereas ideal specimen is very polished and very smooth, so there are no chances of any discontinuity, or there is a minimum chances of any discontinuity, due to which there is no stress concentration in ideal component. So the endurance limit of ideal component, or the component which was used in the rotating beam machine is higher than the endurance limit of the actual specimen, and the factor that establish a relationship between these two is the KD, that is the modifying stress concentration factor. So this was all for today's video, friends. So friend, if you like my video, you can subscribe to my channel. Also friend, you can go to the previous video lectures that I have taken to completely understand about the fluctuating loading condition. So thank you friend.